All right. So on Friday, we talked about molar mass, and we talked about it as a bridge or a conversion between things we cannot measure, atoms, and things we can measure, grams. I cannot measure 6.02 times 10 to the 23rd molecules, but I can measure 63.5 grams of copper. That I can do. So moles is that bridge between things I can measure, grams, and things I can't measure, moles. And today we're going to calculate molar mass of molecules using the periodic table, and then we're going to convert those molar masses into grams and moles. So this is practice for you. Okay. Some pretty simple, some not so simple, but follow along. Determine the molar mass of the following elements and compounds. Calcium. So you should immediately run to your periodic table, look at the left side of your periodic table, and notice that calcium is 40.08 or 0.78. I'm going to go ahead and just use 3 or 4 numbers, if you will. But it's just 40.08. That's what the molar mass is. Remember, the molar mass is not atomic mass. The molar mass is an average of all the isotopes' weights and their abundance. And we're going to do a little bit of practice of that later, too. Okay, so it's about 40.1. Cl2. Chlorine, the molecule, which I will remind you is a diatomic molecule. Remember, diatomic Brinkelhoff are not ever found alone. So they're not found alone. Yes?
So what would you say was molar mass of the average of?
The weights, the atomic masses of the isotopes, isotope weight, and the natural abundance. 70.9? Not good? Yeah. So you realize that since chlorine is Cl2, you had to take the chlorine's molar mass and double it. And once again, the unit we are using is the gram per mole. The number of grams in 1 mole of the stuff, or the weight of 1 mole of the stuff. There's a compound. This is called calcium chloride. What is the molar mass of calcium chloride? Is it 110.18? That's what I got. I mean, in the ballpark. So just add the two together, right? So you have 1 calcium at 40. You have 2 chlorines at 71. So about 111. It's just adding. It's just adding up the parts. Kind of like if you wanted to know the weight of a big Lego model, you could just add up the parts of the individual Legos. All you're doing is adding up the parts of the molecule. How about this one? H2O. Hang in there, Andrew. I said hang in there. It's easier to stay awake if you're actually like working on each exercise too. Not to say that you're not, but FYI. If you're just trying to watch me in my boring presentation, then you're probably going to have to be fighting sleepy all day. But if you're actually working as you go, it's a lot easier. You have something to write. Keep that brain engaged. Hey, Ryan. All right. Okay, so I'm glad you mentioned that. It's wrong, but I'm glad you mentioned that. Okay, so, ladies and gentlemen, take a look at this little number 2. This is called a subscript. Literally means underwrite, writing under or writing down. So a subscript refers only to the thing right before it. So H2O is how many H's? 2. How many O's? 1. For a grand total mass of what? 18. Yeah. You get 1 times 2 for the hydrogen and 16 for the oxygen, for a grand total of about 18. Okay, take a look at that. Let that sink in for a second. Are you doing chemistry?
No, sir.
You're doing homework that you should have done in another class?
Actually,
Okay. So, yes, you're doing classwork you should have done for another class? Let me introduce you to another thing that's new. These are parentheses. They work just like algebra parentheses. Okay, algebra is not a bad word. Okay? No, it's not. So, when you see parentheses in algebra, it means everything in that parentheses, right? In chemistry, it means everything in the parentheses. This 2 means you have 2 OHs. You have Ba, OH, OH. That's all it means. So, a barium and 2 OHs. 2 oxygen-hydrogen combinations. So, work that one out, please. $171? Okay, so if you got a number larger than 100, raise your hand. Excellent. Larger than 150? Larger than 170? Larger than 180? Sounds good. Yeah. So we have a barium plus an oxygen plus a hydrogen, that quantity times 2. So 137 for the barium, 16 and 1 for the oxygen and hydrogen, times 2, so that's 17 times 2 plus the 137, 171. Questions? Then we move on. This is iron 2 sulfate, FeSO4. if you got a number larger than 100 gram per mole, raise your hand. Larger than 130? Larger than 160? Oh, good. 152? 55.8 for the iron, 32.1 for the sulfur, and 16 times 4 for the oxygens. Last one. This one could be a little tricky. So you have how many aluminums? Anyone? 2. How many SO4s? 3. 3 SO4s. So that means you're going to have 3 sulfurs and 12 oxygens. You have to multiply by 12.
So wait.
Yes.
No, it's not it's aluminum.
Wait, so I have a question. Is this how you would write that up then? Like, always copy?
There is no one way to do it. Whatever way looks most comfortable to you, you do that. Okay, it sounds like from the chatter that you got the answer. Does anyone need more time? Okay, take another minute. 1 more minute.
Oh, SO is the third. Yeah.
I don't care if you eat it. So you don't have to like hide it.
Then we got
All I care about is you don't feed the ants. All right, if you got a number larger than 100, raise your hand. Larger than 200. Larger than 300. Larger than 400. You get about 340 something?
Yeah.
Excellent. Now, ladies and gentlemen, if you get a number pretty close to what I got, you're in good shape. If you round at a different time than me or your neighbor, that's okay. So if you got like 341, great. 343, great. Okay? Don't worry about like, when do I round? Don't worry about it. If you're doing the math right, it's going to be impossible to get it wrong, depending on when you round. Okay. Now's a great time to ask for questions. Are there any questions? Give me a thumbs up if you're comfortable with this so far. Excellent. Okay. Now this is where the meat and potatoes of molar mass comes in. Converting between moles and mass. Okay. You just told me that water is 18 grams per mole. So if I said, how much does 2 moles weigh? You would say what? 36 grams. You take that 18 and multiply it by 2. Okay? So if I said copper is 63.5 grams per mole, if I had 63.5 grams, I would have 1 mole. Okay? So what we're going to do now is we're going to do conversions between moles, which we can't use, and grams, which we can use. Because it allows us to go from moles to atoms. We have to look at. That's a really good question. When we do chemical reactions, everything will be in moles, not grams. So we have to be able to get to that unit we can't use. Okay. So I'm going to show you a technique. Okay. Here's the word exercise. Sodium has an atomic mass of 23 grams per mole. How many moles do you have in 115 grams? Now, there are people in the room that can do this in their head, but I'm going to show you a technique that we're going to use for the next 4 months. It's going to be very, very handy, and it's pretty much all the math we're going to need for the rest of the semester. It works like this. Are you ready? It's called factor label, also known as the T-chart. So, we make a T. Or sideways cross. In this block, you put your starting unit. And in this bottom block, you put your conversion. Now here's the cool thing about the T-chart. You don't have to worry about getting your math mixed up, because whatever unit is in this block will also be in this block. Whatever unit is in the first block will also be in the second block. Unit, not number. Unit. Whatever unit you have in that first block will also be in that second block. So, let's write our starting numbers and units in. We're starting with 115 grams. 115 grams. Exactly right. Grams will be in this box. And the thing we have in our conversion is gram per what? Mole. Gram per mole. Okay, so it says the conversion is 23 gram per mole. You drive down the road, you look at your speedometer, and it says 60 miles per hour. 60 miles per how many hours? 1. The conversion is 23 gram per mole. 23 gram per how many mole? 1. Boom. And then it just becomes a little arithmetic exercise. I don't like arithmetic. I hate math. Arr. Yep. If you hate math, just make your calculator do it. All you have to do is set it up. Get your calculator to do the math. 5? 5. 5. 5. Cinco. 5. Cinco in German. Boom.
We not put anything in this area?
Nope, nothing.
Nothing ever?
Nothing ever. Jessica asked a really good question. Do we ever put anything down here? No, we don't. Sorry, Jessica. We don't put anything here. It's 0. It's not blank. It's not 0. It's blank. How many grams are equal to 3.5 moles of calcium chloride? So once again, make our T. What are we starting with? 3.5 moles, which means what's going to be in this box down here? Moles. Moles. Excellent. And hopefully about 2 inches above in your notes, you have the conversion for grams to moles for calcium chloride.
What? Oh, right here.
111? 111 what per what? 111 gram per 1 mole. Nothing goes there.
Why is it there? Because you can't just make like, you can't just make a
Because it's easier to say T than L with a line.
L with a line.
Nothing goes there.
Oh my god.
Yeah.
Oh, wait.
Okay. I would. So, what is this useful for? If we had a chemical reaction that required 3.5 moles of calcium chloride, and we will do this stuff later on in the year. Be like, I need 3.5 moles of calcium chloride. I don't know how to I don't know how to measure that out. I do know how to go into the back, get the calcium chloride, and put it on a balance and weigh out grams. I don't know how to weigh out moles. I can weigh out grams. How many grams should I weigh out? 388.5 grams.
That's what I was going to say.
See, that is something I can weigh out. Okay, I mentioned that there is a little, in the upper right corner of the slide, I mentioned that there's a trap a lot of people are going to fall into if you're not careful. Don't cross multiply. This is not a ratio. It's not a proportion. Okay, so don't cross multiply. Please. You know what I mean by cross multiplying, right? Okay, so don't do that.
Multiply across, right?
Yeah, you just multiply across.
Oh, wow.
Okay, let me share with you the beauty of the T-chart. If you're using it and you master it, and you probably will, probably in the next 10 minutes, if you mastered this in October, then this will be no problem in December.
Wait, I'm
Guys,
I'm going to move back to the
no going back to geoscience. It's, you just make your calculator do the work. If you master this, then this is just as easy.
Why do we need to do this?
Excellent question. If we were using gases where we can't measure out the grams, we can measure out volume, then we add another box. If we were using liquids where instead of measuring out the grams, we use density and measured out volume, then we need another box. And when we have two things where we convert from one to the next, then we need two more boxes. But again, don't let this scare you. If you handed a 5-year-old a textbook and say, you'll be able to read this, you'd be like, no, I can't. I can only read cat, dog. Okay, you're in the same boat. Right now, we're right here. And when you've mastered this, this will become very easy. Yes?
So, I'm having trouble figuring out where, like,
Guys, I want to hear Jesse's question.
grams are supposed to go, like, I'm having trouble figuring out where
LA grams?
plug it in grams.
Okay, so here's the question. Where do the units go? You have to read the word problem. Using the word problem, that will tell you what your starting unit's going to be. Here's the other thing. There are actually two. Two things. The word problem tells you what the starting unit's going to be. That starting unit is going to come down into this box here.
Right.
And you never, are you paying attention?
Yeah.
You never start with a conversion. Remember how we said this one's going to be blank?
Yeah.
Never start with a conversion because that won't make this blank. The conversion will always be the second block. Always.
Okay. So,
Can you handle this one on your own?
so we don't have to worry about, like, two or anything.
I'm I'm not sure what you mean by 2.
Like in calcium chloride, 2 subsets.
Oh, you do, because that tells you how much the conversion is. That tells you the gram per mole conversion. So you'll need to use the O2 for silicon dioxide.
Okay, but like,
So